Welcome back to Applied Algebra and Trigonometry. This video will talk about the half-angle formula. Please raise your hand if you have memorized the sine of 15 degrees. If you have memorized that and other such angles, then perhaps you should be teaching this course. I have not memorized that. However, I have memorized the sine of 45 degrees and the sine of 30 degrees, so I can get to 15 degrees by using a division. However, I can also get there by doing the sine of 30 degrees divided by 2. Thus, this angle measurement can be considered the half angle of 30 degrees, and thus we have the name for the half angle formula. Here is the half angle formula for sine, and notice the tricky part about this. The angle you're looking for is not alpha. Alpha is what is in here. So when you are trying to find a trigonometric ratio for an angle with which you are unfamiliar, say 15 degrees, ask yourself, if I double that angle, do I know then the functions of the angle? In other words, I'm looking for the sine of 15 degrees. Do I know sine and cosine for 30 degrees? Oh, yeah, I do. So I can use a half-angle formula. Before we evaluate that, let's notice some things about this half-angle formula. First, we're going to be taking a square root. And when we do that, we are going to be taking both the positive and the negative square roots. We have to consider both of those. Also, we have sine, and usually sine doesn't change in the formula, or it has a different pattern. This time it goes straight to cosine, and we have a negative in this sine formula. Not usual for sine, what we've seen previously, but there it is. So notice those things about this formula. And now let's start evaluating. We have plus or minus the square root of 1 minus what is the cosine of 30 degrees? Let's see. I have a 30, 60, 90 triangle, so my sides are 1, 2, square root of 3. The cosine of 30 would be the adjacent over the hypotenuse. So square root of 3 over 2 divided by 2. Now be very careful as we turn this into a complex fraction to remember to extend that radical sign all the way down so that the 2 at the very bottom in the denominator is still under the radical. Okay, we need a little more room here. Okay, now we have a complex fraction that we need to simplify. So let's do that by, instead of dividing by 2, multiplying by 1/2. I thought those 2's were going to cancel, didn't you? Okay, so we have square root of 2 minus square root of 3 over 4. Well, we can take the square root of the numerator and the square root of the denominator. So we're going to have plus or minus square root of 2 minus square root of 3. Not much we can do about that right now, but it is over 2. That is as far as we can simplify that by hand. So the only thing you can do now to get a more understandable answer is to go ahead and punch it into your calculator. So 0.2588, let's go to the 10,000ths place, and negative 0.2588. Those are the values for the sine of 15 degrees. Or is that true? Because we want the sine of 15 degrees. This isn't telling us the sine that 15 degrees is a reference angle. It's saying we are looking at 15 degrees. Which is going to be in the first quadrant, which means it cannot be negative. The sine in the first quadrant, along with all other trigonometric functions, is positive. So we've worked with the half-angle formula for sine, but shouldn't there be a cosine half-angle formula? Yes, there should. The cosine of alpha divided by 2 equals, it's also a radical, positive and the negative square root of 1 plus cosine of alpha divided by 2. Surprise! Both of our half-angle formulas have cosine within them, whether they are sine or cosine. The difference is the operation that goes on underneath that radical. Positive for cosine, negative for sine. All right, well, what if we did tangent? What would the half-angle formula for tangent be? Well, the tangent of alpha over 2 would be equal to the sine of alpha over 2 divided by the cosine of alpha over 2, which equals 1 minus the cosine of alpha over the sine of alpha. I will leave the derivation of that formula to you, but let's work with an example for cosine. So let's say you're looking for the cosine of 105 degrees, but you've already been given, or you have found already, that the cosine of 210 degrees is negative 0.8660. Well, if you have that, then you can find sine, or you can find the cosine of 105 degrees, because 105 degrees is 1/2 of 210 degrees. So let's go ahead and find that cosine of 105 degrees by using the fact that we have, the cosine of 210 degrees. We can put it right into the formula there. So we have 1 plus the negative 0.8660, be careful with your signs, divided by 2. The 2 is still under the radical, and we can evaluate that to be plus or minus 0.2588. Well, which one is it? Is it positive or is it negative? 105 degrees. Let's take a look at where 210 is first. 210 is down here, and the cosine in the third quadrant, all students take calculus, is negative because you have a negative x value and a negative y value, and the hypotenuse is always positive. You will always have a negative cosine in the third quadrant. But we're not there. We're in the second quadrant with this. What about cosine in the second quadrant? Is it positive or negative? You have a negative x, a positive y value. Cosine in the second quadrant here of 105 degrees is always negative. So we will not be using the positive. Our answer will be negative 0.2588. So in this case, we were given an approximate number. We weren't given a ratio as the value of our cosine. Let's look at a case where you may be given a ratio as a value of a trig function and be asked to find another one using the half-angle formula. So let's look at finding the cosine of alpha divided by 2 if the sine of alpha equals negative 4/5. But we're going to have some special constraints on our possible answers. Alpha must be between 90 degrees and 270 degrees. Those are not our usual constraints. Why do you think I might be constraining it here for this example? I'd love to hear your reasoning when we get together next online. Of course, it always helps to sketch things out and put these angles on a Cartesian plane. All right, so we know the sine of alpha is negative, and we also know it has to be somewhere between 90 degrees and 270 degrees. So where is sine negative here? Sine is positive in the first quadrant and the second quadrant. Therefore, alpha must be down here. And the sine of alpha is opposite over the hypotenuse. The hypotenuse is always positive. And in the third quadrant, your y value is always negative. Special triangle there. It's not quite to scale, but that other side would be 3. There, we'll move that over just a little bit to leave a little more room for everything. When we are measuring the angle here, alpha is the measure of the standard angle. So half of that, halfway around to that angle, should put it somewhere in here, shouldn't it? In the second quadrant. All right, I know the half-angle formula for cosine is written over there on the left, but I've written it over here on the right so we can see it immediately with this problem. All right, but I do see a problem. I have the sine of alpha up here. I do not have the cosine of alpha. However, since I have already written out what it should be, I can, from the reference triangle that I've drawn there, I can figure out that the cosine of alpha is equal to the adjacent side. Whoop, somehow my negative got erased. Sorry about that. In my editing process, the cosine is negative 3 divided by 5. Now that I know what the cosine of alpha is, I can plug it into this formula. So what I have now is the cosine of alpha divided by 2, which is the value we're looking for, is equal to plus or minus the square root of 1 plus the cosine of alpha. I'm going to substitute the value that I have for the cosine of alpha, which is negative 3/5. I'm not just substituting for alpha, remember. And if we go ahead and evaluate this, we find that the cosine of alpha divided by 2 is equal to the positive or negative square root of 5 divided by 5. Well, where is the angle we're looking for? The angle alpha divided by 2 is in the second quadrant, and in the second quadrant, cosine is negative, it is not positive. Therefore, we have to exclude the positive case. So what is square root of 5 over 5? A little bit hard to pinpoint conceptually. If you plug it into your calculator, you get negative 0.4472. Because this is an applied algebra class, the half-angle formula is often one that I skip, because in the field you're not going to be chasing around with radicals. You're going to be using your calculator directly most of the time. So especially with a half-angle, instead of the half-angle formulas, you'll just punch the cosine of the angle you want to find. The other methods can be useful occasionally. This one, not as much. You need to be aware of it, work with it a little bit, give it some practice, but we're not going to cover it actively in class. In fact, rather than using these formulas to directly evaluate an angle, more likely you would use them to simplify an equation which you're going to be using repeatedly. So without getting into a lengthy explanation of where this formula comes from, it can be found by analyzing the path of a sliding particle, but this is a little bit awkward to work with, a little bit awkward to put into your calculator. Of course, you could always program it into your calculator. But anyways, if you did need to simplify it, we could do it this way. This would be equal to, we have a common factor. We can take out the greatest common factor. 1 minus the cosine of theta. That almost looks like a part of one of our formulas. What if we did this? 8 is equal to 16 divided by 2, right? And we can rewrite that in different ways. We could rewrite that as 16 over 1 times, close that parenthesis, 1 minus the cosine of theta divided by 2. Oh, but we can take the square root here of 16. It can come out of there. So we would get 4 times the square root of 1 minus the cosine of theta divided by 2. Well, the square root of 1 minus the cosine of theta over 2 is the sine of theta divided by 2. And that is still multiplied by 4. This is only the positive case. That's all we're going to be using here. But why not look at both the positive and the negative cases? Well, the reason is we didn't decide to take the square root. It was given to us originally. Written this way, it indicates that only the positive square root is to be considered. We now have a formula that is easier to put into the calculator. That was the purpose of applying the half-angle formula here. I have given you only the briefest introduction into all the many ways you can work with half-angle formulas, but I hope it was informative. I will see you the next time we meet online.